Do you want your online store to be ultra-fast, fully customized to your needs, and scalable to more than 1 billion items? Imios is an ultra-fast PHP e-commerce framework. Imios, next level e-commerce. Try it now.
If you're running an application at scale in public or private clouds, you have to tame almost boundless complexity. Datadog brings together all this observability data with infrastructure metrics, traces, and logs in one integrated platform.
Vonage is a cloud communication platform that lets you integrate voice, video, and messaging into your applications. We have a load of helper libraries, including a Laravel package and a client library for PHP. You can find out more about us at developer.nexmo.com.
Tankersley, and I'm the PHP developer advocate at Vonage, formerly Nexmo. Now, Nexmo might sound familiar. We're one of the notification channels that is actually built into the Laravel framework, but today I wanted to talk to you about a project that we've been involved in for the last few years called OpenAPI. Now, OpenAPI is an ecosystem that's really grown over the last few years, and it's a tool set that we find really helps us document our APIs more clearly and provide extra benefits for the developers that actually want to use our API. So what exactly is OpenAPI? Well, taken directly from their website, it's an API description format for HTTP APIs, which is kind of a really nice way of saying that it's just a specification. OpenAPI has grown out of the Swagger project, so if you've used Swagger in the past, many of the concepts that I'm going to talk about today will look very familiar. But at the end of the day, OpenAPI is a fairly robust and mature description format for describing your APIs. One really kind of important thing to note here is that it says HTTP APIs. OpenAPI aims to make sure that it's easy to understand and describe any HTTP API, not just RESTful ones. REST APIs are awesome, but they don't really work for every single situation. Also, if you're coming from a homegrown API that doesn't really follow any major output formats or URL structures, or maybe you're not using anything that's RESTish, you might be using something like RPC, some other API format, OpenAPI itself doesn't care. It wants to just make sure that you can actually describe and document your API no matter what kind it is. And while it does have some leanings toward REST based on its own past, OpenAPI wants to help you describe your API as long as it works over HTTP. So now, why would you want to use OpenAPI if it's mostly just a description format? It's great that you can write down what your API looks like, but you have source code. Your developers control through that. You can write your own documentation. Well, it's not so much the OpenAPI document itself that's important. It's the ecosystem that has kind of grown up around it. Out of the gate, what most people use OpenAPI for is documentation generation. And this kind of comes twofold. When you write out your OpenAPI spec, you automatically get documentation. The specification is very verbose, to a good part and a fault sometimes, but you end up with a nice little document that describes everything that's going on. On top of that, there are actually documentation generators that will take your specification and it will generate actual HTML code or whatever format you want for your documentation. So not only do you spend the time documenting it in a programmable sense, you can actually then turn around and turn that into whatever kind of actual end user documentation you want. This is what a lot of people use it for and kind of stop there, but there's a lot more that you can do too. The other nice thing about OpenAPI is this idea of description as code. So you've probably heard of the idea of configuration as code, which is where you store all of your configuration in files that can then be used by tooling to set up servers or deploy code, whatever. This is the same general idea. The point is that you have a central place where all of your API specifications are stored in a very easy to read format that is very easy to use for both tooling and humans. So this is something that we do. If you go to nexmo/API specification on GitHub, we have all of our public APIs documented with OpenAPI specs. So anybody can go through and see what the configuration is in a fairly easy to read format. On top of that, because it is just a text file, they're very easy for us to work with, both from a change perspective and a review perspective. So many times as we go through and we iterate an API, either through adding examples or refactoring or adding new products, we will push up a new OpenAPI specification. It goes through the normal GitHub review process. We can just do diffs, all sorts of stuff with it. And I can pull that down. I can use that with internal diffing tools if I want to use that. It doesn't really constrain us in any way because they're all just text files. The other nice thing is they're all stored in one specific place in the same format. So even if we're building out APIs in different languages and different frameworks, I don't have to dig through any code to find anything. It's all in one easy to read place. And I've mentioned it a couple times so far, but the tooling integrations are probably where you're going to find the most bang for your buck with OpenAPI. You can go to openapi.tools and there will be a whole host of things that you can download and play with, including documentation generation, linting, code generation tools, which I'll talk about here in a second. Hundreds of applications that you can download to help you work with your OpenAPI specifications. In fact, you can even go so far as to build your own tools because the specification is so well documented and robust. So here we actually have developer.nexmo.com. Most of our API documentation is 100% generated off of our OpenAPI spec. So over on the overview on the side, all of those descriptions, those all come from our OpenAPI spec. What HTTP verbs are used comes from the OpenAPI spec. If I need to change the URL for something, I go into the OpenAPI spec, make the change there, goes through the review process like I said, and then this is all regenerated off of that. We've actually whiteboxed it. You can actually use it yourself if you want, Nexmo-OAS-renderer on GitHub. But everything from the examples to the actual descriptive text comes completely from the OpenAPI spec. So there are tons of other documentation generators out there too, to the interactive ones. But this is something where if you need to build your own tools, they're very easy to build off of the specification because you can go online and actually look to see what that specification is. Now, when you're dealing with any API, whether it's from the legacy side or coming from a greenfield project, the first thing you want to do with OpenAPI is actually get it documented. And even if it's a legacy application, I still like to consider this designing an API. You're going to sit down and start to look at what your API looks like or how you kind of want it to look like and see where kind of the rough edges are, how it actually starts to fit together before you ever have to write any code. And this is kind of powerful. Think of it kind of like TDD for API design. So like I said, the OpenAPI spec just helps you describe what your API looks like. And there's 5 main things that the OpenAPI spec really kind of helps you define. It does get very, very granular from these, so don't worry that it's this kind of vague 10,000 foot view. You can get very, very detailed in what you do. But there are 5 main things you're going to look at when you're going to start to describe your API. The first thing is information about the API itself. So this is the information header, or as they call it, an OpenAPI object. This is going to be at the top of every single OpenAPI document. So here we can see we have an OpenAPI version. Ours that I pulled this from is 3.0.0. I think 3.0.3 is the current version. But you always open up with what version of OpenAPI you're using. And this is because there are multiple versions of OpenAPI, and that can impact how tooling runs. but this is strictly just to help tooling understand what format this is in. Then we have an information block, and this is just some contextual information about your API itself. So here we can see we have an internal version number of 1.2.5, so our voice API is on that. This does not impact any URL structure or anything like that with the system. So it just strictly is for us to say we are on 1.2.5. If we make a change, we can argue over should it be 1.3, 1.2.6, should it be a 2.0, whatever. This is just strictly internally for us. Same thing with title and description. These just help provide some additional context for what your API itself does. And then, because if you're publishing these things, you probably will have people ask questions about them, so you can provide some contact information. So here we have the email address and the URL that you can find more information at. So if anybody has any questions, they can email or visit these sites and hopefully get some more information. Now, one thing that's not strictly required but is very, very useful for tooling is the servers block. And this is a list of servers where your code will actually run. These are kind of the base URLs for everything else described in the document. So you should be able to go to api.nexmo.com/v1/calls and then whatever paths we describe, and those should exist there. This is mostly used for tooling, which I'll go over here in a little bit. If they need to actually interact with a real production level API, they know where to go through. So once you've got some information about your API, we're going to go through and define what endpoints are available. This is where you start to get into what does the developer need and want. So here we can see that this API has 5 paths available. We have slash or root, we have /UUID, and then off of UUID, we have stream, talk, and DTMF. One thing you can also notice is that we do offer placeholders through OpenAPI. So while slash doesn't have any placeholders, the rest of them have a placeholder for UUID, and the OpenAPI spec understands that something will be put into here by the user. This is also the first chance you get to actually kind of sit down and think about what is the structure of your URLs and whether or not they kind of make sense. So slash and /UUID, those are pretty restful. Those are resources that are generally used for getting all of something, like all of the different entities that you have with slash. And /UUID, we would expect would return a single one. But then we have the stream and talk and DTMF. So this is the first chance you have to kind of sit down and see whether or not something kind of fits. If you're coming from a legacy API, there may not be a whole lot of stuff you can do with this. You may, your only recourse may be document these as tickets and refactor later on. But if you're working on a brand new application, you can sit down and say like, well, does this actually make sense? So you can go through and kind of tweak things long before we've written any code whatsoever. So now that we know what paths are available, we need to know what the requests themselves look like. So once a developer finds a route, how do they actually start to work with it? So here we'll go through, we'll pick a path. We're just going to pick root because that's a fairly easy one. And the first thing that we document is the HTTP verbs that are used. So like I said, OpenAPI is not technically RESTful, but because it is HTTP, you still have to deal with things like verbs and response codes at a very, very basic level. So here, this root path will take a post and a get, and that's it. If you send a put or a patch or an options or whatever, our specification says we're not going to do anything with those. So we will probably return some error. Once you start to go through and document the path, you start to open up a lot of different options here as well. So if I look at the get, we can actually go through and start to describe what that request should look like when you make a get request to slash. So here we have a summary and a description, just some information about it. And then we have the operation ID. This is very much a tooling key, but if you're using any sort of code documentation or code generation, the operation ID will be used to kind of reference things back and forth. After that, we start to get into the kind of the meat and potatoes of what goes into the request. And for especially get requests, we have a thing called parameters. Parameters are both things that go into the query, but also things that can go into the body as well. So we can see here we're going to have at least one thing called status, and that's going to be in the query. We specify it's in the query because technically you could send a request body with a get. You shouldn't, but you could. But if this is a post or a put or something like that, we would want to specify that it's in the post body as opposed to the query string. Then we can get a description for what this specific parameter is. And we start to get into actually some information about the data coming back and forth in our specification. So we can see that there is a schema for status, and that is a string. So whatever we pass in here should be a string. It's not expecting like an integer, like a 0 or a 1 or a -1 or something like that. It's actually going to be expecting a string. And here we can see an example that we've added, which is called started. So whatever status is, it's probably going to be an English word all in lowercase. And it's probably going to be something like started, stopped, whatever. So here we can also see we document examples with OpenAPI. So OpenAPI examples can exist at the field level, like here we have here for just status, or you can have entire pre-canned examples that can actually be referenced by name if you want to test out things. So, but here we're starting to get into this idea that not only do we know what parameters are part of the request, we can start getting deeper information about this. And that helps developers write their code, especially if they're using strict typing, but also know what is supposed to be coming back in the case of a response. So once we know how to make a request, we need to know what that response looks like when it starts to come back. So now this is the same general idea. We're going to go back under get, and then we're going to have a responses section. Now, again, OpenAPI, not technically REST-ish, but it does need to know how to respond back on HTTP codes. So in this case, we're going to have a 200. You can have a 200, 204, whatever. You can also document all of your errors through here as well. So both 300, 400s, 500s, whatever ones you have, you can go through here and document exactly what these responses look like. This is also another great place with a legacy API. If you've got multiple responses on a 200, that's probably a code smell. You probably want to look at either swapping those things out into different URLs or providing a different way to actually get that information back. But we start off with a response code. So 200, generally, like our description says, that means it's going to be an okay response. And then you can have content that goes back. So content is actually split up by acceptance. So if your client says, oh, well, give me JSON, you can describe what the JSON format looks like. If they are something that's older or they need XML, you can actually describe XML documents that come back. So you can actually have different responses based on what the client wants before you have to do any actual code. So you can sit down and think about what information needs to come back, what makes sense per content type. So much like with a request, we have a schema. So we are going to return an object. So this is just going to be a bare JSON object as opposed to an array of objects or something like that. And for the example, we're going to have at least one property called count, and that's going to be a type integer. But so from here, you can go through and start to document what these response types look like. Now, while we're slightly RESTful leaning with some of these, like defining HTTP verbs and response codes, when it comes to the actual format of the output, that is totally up to you. So later on, we're actually going to look at using the JSON API schema for the output of all of our stuff, but you can go through and use whatever you want. You just describe it out in the schema. Now, one thing that's really nice about responses is, and a lot of the stuff in OpenAPI, is this idea of reusability. One thing that really annoys developers is when fields are inconsistent or responses are inconsistent between different calls. So if you've ever used an API and like you hit like get users and the root returns user underscore ID for all of its users, but then when you actually retrieve a specific user, you just get ID. That's really annoying. Or if the structure is different, not just the order of things, but like fields are missing between different responses or they just don't make sense. OpenAPI has this thing called a component, which allows you to reuse different things. So I've stolen this from our conversation API, but you can reference components and it will drag in these other reusable things throughout the system. So on our response, this was actually getting a specific conversation. So on a 200, I'm going to return whatever this thing called conversation light is. And I can reference that multiple times throughout different pieces of the document. So I can go down to the component section and then responses and conversation light. So we'll see in here, this is actually kind of giving us a path to where we need to go. And this is actually going to be a response. So we have a content of application JSON, it's got a schema, and it has its own properties. The other cool thing is that you can reuse things down to the individual field level. So ID references its own component. href references its own component. Why might you want to do that? Well, you might want to describe what those things look like. In the case of the IDs, there are regexes for describing UUIDs. For hrefs, what do we expect those things to look like? So you can actually see and reuse these pieces over and over and over so that you get nice, consistent responses and then build on top of those responses for whatever the developer expects. And then if you make a change in one place, those will propagate out to other places as well. And I kind of skipped over it a little bit because technically it's part of the request, but you can also specify what your authentication methods are. Most APIs have some sort of authentication, and we need to let the user know what those are. So if I go back to the actual get request for root, I've added a new section here, and that is security. And you can reference a security that you describe. So in this case, it's a bearer auth. So I know that for my API, I need to send a token along in the header with some sort of token. So if you're using token secret, key secret, or just a token in the query parameter, you can describe all those things out. So that way the user knows exactly what they are supposed to supply. Now you might be thinking, hey, I hate writing YAML. Well, there is JSON. I don't particularly like the format. It's a lot more verbose than even the YAML stuff. But you may also say, like, I don't want to write any of this stuff by hand. This is a lot of stuff. And I will fully admit it is. It's just a good idea to know what a lot of things are happening in the background. So if you don't want to write any of this by hand, and I don't really recommend that you ever do, there are tools that build a lot of this stuff out for you. One of the ones that I love the most is Stoplight Studio by the Stoplight Group. The Stoplight Group makes a lot of open source tools around OpenAPI. So this is one of the better ones that we use, and I kind of tend to play with day in and day out. So Stoplight Studio allows you to actually go through and document what your API looks like through basically an IDE. And the nice thing is it's just building that YAML file in the backend. So you don't have to worry about this being locked into anything. It's just going to generate a file on your desktop that is just YAML that you can port around anywhere you want. You can wire this up to a GitHub repo and start to share things back and forth with that. It's a really wonderful project. Now, once you've got your API kind of sketched out, or you're kind of building it and going through, you're going to want to eventually start to kind of use the API and see if it makes sense. So using the tooling with OpenAPI, there are a lot of tools that allow you to actually prototype and mock these APIs. One of the more heavily used ones is called Prism. This is also by the Stoplight Group. This is just a tool that will take your OpenAPI spec and it will generate a mock proxy server for your API that you can hit and get back kind of dummy data. So it's just an NPM module. So once you install it, you just say Prism mock and then give it a YAML file. So I'm going to give it the voice.yaml file example I've been using so far. And we can see that it starts up it'll generate a post request on slash. It gives us a get request with a whole bunch of query parameters so we can see status there. And then we can see some get inputs with what looks like the UUIDs. So we can see that. We've got stream, talk, DTMF, all of those things. Prism will go through and mock all of those. And if you turn around and use a tool like Postman, you can actually hit the URLs that it gives you. So if I grab that really long get request with all the query parameters, if I throw that in Postman, I will get a response back. This response is totally based off of whatever OpenAPI description we give. So we can see count there at the very top, which is the very beginning of the response that we had skeletoned out. But we can also see there's a page size, there's an underscore links, there's an embedded with a calls object in there, which actually links everything or lists everything all out. So Prism will take your OpenAPI spec and generate responses. In some cases, it will actually use the examples that you give. So under calls, we have a UUID and a conversation UUID. Those are the examples that we gave in the OpenAPI spec. So you can actually get real life data coming back that looks correct for your server to use. Same thing with the phone numbers, the to and the from. Those are examples documented in the OpenAPI spec. If we change something, we can go through, update the example. If we need something more clear example, we can fix all of those things, and it's all part of the OpenAPI spec. Now, if you're using Stoplight Studio, you don't have to install Prism itself. It's actually kind of built in. If you go down and click on, in the lower right-hand corner, there's a little mock server. It almost looks like just like a status badge. If you click that, you'll get a little pop-up window with basically the same thing. About the only difference is that the examples look slightly different, and the URLs it generates, like the usually the port it's using, are slightly different, because OpenAPI Stoplight will actually mock and run multiple specs if you need to. But the same thing, I can take the URL that I get from Stoplight Studio, throw it into Postman, and I will get back the response that I expect. So now if you've mocked out your API, you've designed it, and you're pretty happy with it, the next thing you can do is start to actually generate some of that boilerplate code to get your API up and running. If you're starting with a prototype or a brand new project, you can actually generate server stub code. So there are a bunch of different languages out there. You've got ASP.NET, you've got Golang, you've got Java, PHP, Node.js. They'll actually build an Express app, Ruby on Rails. For PHP, I think there's 5 different server stubs that you can generate. But you can go through and actually generate out boilerplate code and be up and running, and all you basically have to do is just wire in your data. Same thing for client SDKs. If you want to quickly publish a client SDK or use that as the basis for your own SDK, you can do the same thing. So we don't do this at Vonage. All of our client SDKs, like PHP, Java, all that stuff, we write by hand. We just use the OpenAPI spec as a reference. But if you wanted to very quickly generate an SDK for someone during a prototyping phase, you can do that. And you just like generate a PHP client SDK, and it'll generate those things. So let's go ahead and go through the process and make a very quick API in Laravel to see how this whole process gets put together. So we're going to build a very small to-do app, by no means exhaustive, but we're going to assume that it's a standard REST interface. For this, I think REST works fairly well. And we're going to use a JSON API format for all the output stuff. And hopefully what we have at the end of this is all of the Laravel boilerplate code that we need to get this working. So first thing I would do is I would go into Stoplight Studio and start to work on the API and start building that out. So I already have a pre-canned OpenAPI spec. If you go to bit.ly/Laracon EU-OpenAPI, you can go grab this sample code and actually either paste it directly in here or open it up however you want. But if I'm going to be building an API, I'm going to go into Stoplight Studio and I'm going to start describing what the API looks like. So we're going to give it basically 2 routes with a couple different HTTP verbs each. We're going to have a slash, which is going to be getting all of our to-dos as well as creating a new to-do. And then we're going to have slash to-do UUID, which will get us a specific to-do, allow us to update it, and then delete it. Now, as I'm building this out, I'm going to be using the mock server built into Stoplight Studio with Postman to see if everything looks correct. Once I'm pretty happy with this, we will go into OpenAPI generator and we are going to generate some code. So the skeleton generator takes an input of whatever the YAML file is. So this is the todo.v1.yaml, which I built using Stoplight Studio. We're going to give it a generator, which is php-laravel, and an output directory. So I'm just going to throw this in a directory called Laravel. So once I run this, it'll actually generate a bunch of code for us. And so here is our OpenAPI document. And then here we can see inside of routes, it's going to generate all the Laravel code. We'll end up with a routes folder and an API.php, which we kind of expect, with calls to the route facade, with post and get and delete and all that kind of stuff that we expect, pointing to a controller. And if I go look at the controller, which is just a default controller, we can see we've got create to do and get to do's and things like that. They're all set up to all be wired up. By default, it's just going to return a request saying, hey, why don't you implement this? But the fact is all of the boilerplate code is there. You can go through, start to cut this up. I will fully admit that this is probably not the best controller structure you could do, but it is definitely enough to get working. Now, there's one big caveat with this, and that is that this generates Laravel 5.6 code. So what I usually recommend is generate this 5.6 code, start up your Laravel 7 code in a different folder. and then just copy those files over. So I'm going to go into Laravel/lib. I'll just move those over. There's nothing in those files that technically needs to be changed right out of the gate, because they're just building off some very simple routes and some very simple controller structures. So then if I go into my Laravel 7, by doing nothing but copying those files over, I can run route list, and I can see it actually pulled all those things through, because functionally those two things work. I don't have to go through actually upgrading that whole 5.6 project. I'm just going to steal those two files. So then all I need to do is just run artisan PHP serve. And if I go into Postman and I start to play around with those routes, we can see if I go to /API, because it's in the routes API, it's in the API route middleware, we get, how about implementing get to do as a method? That's exactly what I expect based on this controller. So everything is working perfectly fine. We generated a bunch of the controller structure. We just have to start going in and wiring our data sources and things like that. And that saves a ton of time, I feel. So we're going to take this and I'm going to pass this over to Johannes, and he's going to show you how to actually build it from the code side, taking a lot of that generated stuff and go from there. But again, thank you everybody for having me. Again, my name's Chris Tankersley. If you want to reach out to me, I'm usually Dragon Man Tank anywhere online. So if you've got anything, you can hit me up on Twitter. And you can email me at chris@ctankersley.com. If you're interested in using Nexmo or Vonage, feel free to send me a DM. I have some coupon codes for some credit. I believe you'll also get some credit in the digital swag. But thank you very much. Again, if you have any questions, feel free to reach out to me. Thank you.
Do you want your online store to be ultra-fast, fully customized to your needs, and scalable to more than 1 billion items? Imios is an ultra-fast PHP e-commerce framework. Imios, next level e-commerce. Try it now.
If you're running an application at scale in public or private clouds, you have to tame almost boundless complexity. Datadog brings together all this observability data with infrastructure metrics, traces, and logs in one integrated platform.
Vonage is a cloud communication platform that lets you integrate voice, video, and messaging into your applications. We have a load of helper libraries, including a Laravel package and a client library for PHP. You can find out more about us at developer.nexmo.com.